Okay, in this video we are going to graph a few linear equations. Here are our first two examples. Sketch y equals 3x plus 6 and y equals negative 2/3 x plus 1. Notice they are both in slope-intercept form, y equals mx plus b. And generally when you graph lines, there's a few different methods you can choose from. The first two we're going to use are using the slope and y-intercept. Okay, so let's take a look at this first one. Okay, y equals 3x plus 6. Okay, and it's quite straightforward. You basically sketch your plane and then label it x, y. And what is the y-intercept? It is 6. It should be, this is 6. 0, 6. And the slope is 3. So the slope, as you might recall, is rise over run. So we go up 1, 2, 3, and over 1. Up 1, 2, 3, over 1. And from there, you have your graph. And that is 3x plus 6. Okay? And in our second example, you would have y equals negative 2/3 x plus 1. Okay, so again, you start with your coordinate plane and label it x, y. Okay, and negative 2/3 x plus 1. So we will start with 1. This is our intercept, 0, 1. Okay, and notice the slope is negative 2/3 x. So the rise is negative 2. So down 2, and the run is over 3. Down 2 over 3. Of course, you could also make the argument that it's up 2 and over negative 3, in which case you'll have the same result. And notice that our graph goes downward, okay? And which, of course, fits a negative slope. In the next pair of examples, we have two linear equations. Notice they're in standard form, ax plus by equals c, standard form. And again, we're going to sketch them. And a lot of students will simply defer to the previous method, which is using the slope-intercept form. They'll take this equation, let's take the first example, and they might say, well, this is 3y equals negative 2x plus 6, using some algebra. This is y equals negative 2/3 x plus 2 by dividing by 3, and then they'll graph a sketch using that formula. But there's another way to do it, which I actually prefer because it uses fewer steps. It's using x and y intercepts. So let's take a look at this equation. And basically the premise of this is if you can find the x-intercept and the y-intercept, you have 2 points on the line. And with 2 points, you simply draw a straight line through them, and you have your graph. So let's take a look at this. I'm going to first draw my coordinate plane. Okay, and again, we will label it x and y. And let's take a look at this equation. We have 2x plus 3y equals 6. So let's find the y-intercept. The y-intercept is, of course, the point where the line goes through the y-axis, the y-intercept. And the coordinate is going to be 0 something. Let's call it b. Okay, and if it's 0b, we just need to plug this point into the equation. So we have 2 times 0, substituting 0 in for x, plus 3 times b equals 6. And we end up with 0 plus 3b equals 6. Therefore, b equals 2. Therefore, our y-intercept is going to be 0, 2. Okay. Similarly, if we want to find the x-intercept, we are reminded that the x-intercept is the point where the line will go through the x-axis. So it's going to be somewhere here. Okay, and that coordinate is going to be something 0. So let's take this and again substitute it back in. So we're going to have 2x plus 3, and substitute the y value of 0 in equal to 6. Therefore, 2x equals 6. And our final equation will be x equals 3. So our other coordinate will be 3, 0. And there we have our two lines, our x-intercept and our y-intercept. And we simply draw a line through both points. And we have our graph. Okay? So let's take a look at the second example. It's a little bit bigger. We have 7x minus 3y equals 28. Again, we could rearrange it and use another method. But again, in this example, we will use the method of finding intercepts. And so we'll draw our quick coordinate plane, our y-axis. So this is x, this is y. And let's look for our y-intercept. That, of course, occurs when you have a value of 0 in your x term. So 7, 0 minus 3y equals 28. Therefore, negative 3y equals 28, and y equals negative 28 thirds, which is 9 1/3, negative 9 1/3. So one of our points is going to be 0, negative 28 thirds, down there. Okay, and to find the other value, we will substitute 0 for x. I'm sorry, 0 for y. So we have 7x minus 3 times 0 equals 28. Okay, and therefore that means 7x minus 0 equals 28. X equals 4. That's convenient. So we have basically 4, 0 as our other point. And again, we have 2 points on the line, and we simply connect the dots. And there's our solution for 7x minus 3y equals 28. And the last pair of examples are two lines, linear equations, that are in point-slope form, point-slope. And again, there's a few ways we could graph this, but the easiest one in my mind is simply plotting points. Oftentimes when I see an equation, I don't want to really deal with it. I'll just plot a couple points and then determine what the behavior is and sketch it. So in this case, we just need to pick 2 points and we'll have our line. So let's start with the first example. Okay, y minus 4 equals 2 times the quantity x minus 3. And again, on the left, we'll sketch our coordinate plane. This is x and this is y. And all we need to do is just find 2 points. So let's pick 2 points. Okay, let's let x equal, I don't know, let's say 4. Okay, if we plug in 4 into this equation, we would have y minus 4 equals 2 times the quantity 4 minus 3. We plug 4 in. And this is y minus 4 equals 2. So y equals 6. So 4, 6 is one of our points. Okay, and then the next point, which we'll just do in our head, let's make x equal, I don't know, let's say x equals 2. Okay, if x equals 2, 2 minus 3 is negative 1. Negative 1 times 2 is negative 2. Therefore, y must be 2. So y equals 2. So our point is 2, 2. Okay. Plug in 2, 2, and we'd have a solution that works. Okay, so we have 2 points. So let's simply put them in. So we have 2, 2. This is 2, 2. And this is 4, 6. Okay, and we simply connect the dots, draw a line through them. Okay, and notice too, by the way, the slope is 2. Rise 2 over 1, rise 2 over 1. So that seems to fit. We could even find our y-intercept if we want to, right? Because that coordinate is here. It's going to be 0 something. So we plug 0 into x, and we get negative 3, which is negative 6, and y is negative 2. So 0, negative 2 is our y-intercept. And of course, we could plug 0 into y to determine what our x-intercept is. Okay? In our second example, we have y plus 1 equals a quantity 1/8 times x minus 2. And same thing, we just pick a couple points we're going to use. And what I'm going to do in this case is I want to make sure I pick to make life easier, I'm going to pick a value that is a multiple of 8 just to make the math a little bit easier. So to get a multiple of 8, let's start with 8. So let's make this group here equal to 8. Okay, and in order to do that, we have to make x equal 10. So let x equal 10. So y plus 1 equals 1/8 times 10 minus 2. So y plus 1 equals 1/8 times 8, right? So that's very easy. That's 1. Therefore, y is equal to 0. Okay? And again, you could check it. This is 1, and that's 1. So one of our coordinates is 10, 0. And then the second coordinate, let's make a multiple. Let's make this 16. So let x equal 18. Okay? Therefore, y plus 1 equals 1/8 times 18 minus 2. Y plus 1 equals, this is 16 times 8, which is 2. So y is equal to 1. So another point will be 18, 1. Okay? And we can pick other points necessary, but we'll just stop here. You can do some more on your own. And now we have our 2 points. So let's sketch the graph. Okay? The y-axis, the x-axis, x, y. This is 10, 0, about right here. And then 18, 1, which is over here. Okay, and notice the slope. The slope is rise 1, run 8. So this is rise 1, run 8. So it's pretty flat. And we just draw a line. And there's our graph. And again, if we wanted to find the y-intercept, we simply put x equal to 0, and we would determine our y value, and that would be our solution.